Thank you, Priyakshi and EVreporter, for giving this opportunity. And thank you, Mr. Chandrasekhar, for this nice presentation, which really, gives way to our presentation that is from Carl Zeiss. I work for Carl Zeiss as a business development head. And our presentation is going to be on the battery topic, starting from battery quality assurance solutions. So Mr. Chandrasekhar mentioned a lot about the production process. So we will kind of button in between about the quality assurance solutions required in those processes, starting from material, that is the particles, what you buy to make your slurry, and to manufacture the cell, modules, tray, and finally fit it in your car. So Zeiss is into e-mobility. So we cater to hydrogen vehicles and fuel cells and batteries and so on. Okay, going forward, a short overview on Carl Zeiss India. We believe we are the pioneer of science and optics. We continue to challenge the limits of our imagination. With our passion for excellence, we create value for our customers and we inspire the world in new ways. I believe you will see a few shades of this in the presentation. These are our founders. Oh, it's not moving forward. Sorry, I do not know. It was working very fine in the start. Try once again, or you want to share the complete screen, or advanced or something.
Manoj, you could also send across the presentation to us, to Priyakshi on WhatsApp, and I'll put it on for you and change the slides for you.
Okay. Yeah. Is it okay now? Yeah. Okay. It's fine.
It's fine now. Yeah.
It's fine. Okay. So right. So going forward, Ranil could be here. So. Yeah. Mr. Carl Zeiss and Mr. Anstabe are our founders. Our company is 175 years old. And we are present, we are an enabling partner to many renowned companies for the last years. And just to give one shade of it is that 80% of the microchips, be it mobile phones or USB cards or anything, is made on Zeiss optics and Zeiss technology. One of the key inventions when tuberculosis bacteria was spreading around was this microscope, which is valid even today in the corona times, and also for the lithium battery solutions. So a lot of innovators have used our tools to make their processes better and figure out new things. We are a worldwide company. We are about in 100 locations. Our headquarters is in Germany, and we are located in 50 countries. 13% of our revenue goes back into R&D. So that is one reason we say that we are in the leading edge of technology. We are divided into 4 verticals. The vertical what I belong to is industrial quality and research. Our solutions will come out of this vertical. In India, we are about 22 years old as a direct subsidiary, and we have a manufacturing facility for eyeglasses, for CMMs, that is coordinate measuring machines, and we have an R&D facility also. We are about a 600-member company in India. This is our office, headquartered in Bangalore. We cater to medical, industrial technology, microscopy, vision care, and sports optics. This slide is one of the most important slides, I would say, a message to all the audience here, the august audience who are from the lithium battery area. This is one of our competence centers in Bangalore. It's about a 10,000 square feet competence center with various technologies, which I will be showcasing it in the next slides. All these technologies are available at Bangalore, Pune, Chennai, New Delhi, Coimbatore, and various locations where you can come and do a pay-per-use. You can come, walk in, and use the machines on a payment basis, depending on the technology. We can give you a lot of solutions for the battery components, very, very, very clearly linking with Mr. Chandrasekhar's presentation on the microstructure, chemical porosity, and so on and so forth. Our presentation on the battery topic start from the overview until the battery tray production. But I would, because of paucity of time, I would be covering only a few topics. So our overview stems into two topics. One is the battery material, that is the ones what you need for R&D, which is a recipe development, which is the most important phase in the battery. And then it moves on to production. Mr. Chandrasekhar was covering the topics of raw material processing, electrode production, cell assembly. So I would also try to move in that direction. I would start with the point number 4, which is the raw material processing and making a cell. So this will be mostly the topic which will start in India as the lithium battery discussion explodes. So we will move forward to quality assurance solutions when you want to produce an electrode. So similar to the previous presentation, you have incoming goods, you have to blend them into a slurry, then you have to coat and dry them, then you do a calendaring process, and then you cut the electrodes. In this process, you need to inspect, starting with the powder, separator, inspect the particle homogeneity, then understand the deformation, then the foil bar, once you cut it, you want to inspect the foil bar and so on, and also the dimensions. So starting with when you put it as a process, we look at cleanliness, raw material inspection, checking the separator, which is a porous layer. In the slurry preparation, you look at the homogeneity. Then in the calendaring function, you look at what is the kind of pressure to be applied and what is the kind of deformation what happens in the electrode material what you have pasted in. And then finally, you cut the electrodes. So first is technical cleanliness. We do have a lot of solutions. We are a microscopy company. We do have a lot of solutions, starting with simple stereo microscopes used for identifying particles of around 20 microns, going up to identifying particles in the range of nanometers, few nanometers. So this is the major task here is actually to avoid the metal contamination. So you must check your incoming raw materials for singular metal and no inclusions of non-metal or metal or fiber contamination in the incoming goods. We have a complete clear solutions. You can identify either from the particle or from the the prepared electrodes contamination. You can check for contamination, identify them, look at where is the contaminant coming from, look at what metal is the contaminant, and then go back and see which manufacturing process might be inducing this metal into your process. So this is an important factor. Also, the housings are also important, where you have to check for cleanliness. There are procedures, ISO standards, which has been laid out, and our software follows it to the T. So you can be sure of getting the right solutions from us. Raw material inspection, this topic was also touched upon in the previous presentation. That is a nickel, cobalt, manganese 111 or 811. The technologies keep changing. So you must have a clear cathode raw material quality assurance process in place, for which you need a complete solution stream, glow box, vacuum box, and so on and so forth. We have these solution spaces available. Even if you do not manufacture, we can give you the complete stream, complete flow of operation to check your raw material. Separator. Separator is again a polymer material, very important material to understand, to improve the performance. So the separated material requires a different treatment. It requires some electron microscopy to look at the microstructure. So this is another role what we play. We have different microscopes to look at the heights of the separator material and how it bonds with the PVDF material, which was another, which is a binder layer. Slurry, as you make the slurry to coat, then you must understand how the powders are homogeneous without breaking the particles. So you could do it in simple microscopes, or you might need the help of some electron microscopy. So this is also available, and in some very high-end battery manufacturing companies, these things are automated, and our electron microscope could be automated to pick up the data, thereby controlling your process in a more effective way. Now, coming to calendaring, that is once you will pressurize the slurry on the aluminum or the copper foil and try to make it as thin as possible. So in this case, yes, you have to look at the homogeneity, the particle size, the morphology, and what is the kind of pressure you should apply. So here again, we have solutions, Zeiss scanning electron microscope, or even XRM. There is another level of technique what you can use. So you have two techniques what we can use to tell you how good is your electrode. This is one of the technology I just want to showcase. Is you are now looking at two electrodes. One on the left is a highly compacted one. On the right is a semi-compacted one, depending on the pressure what is applied in the process. Now, one of our machines, which is shown in the right top in corner, can get into your electrode in detail, layer by layer, and you could understand how is the homogeneity of your material. Is there any foreign layer? Is the material compressed enough, or there are lots of voids and spaces? You could look at it. This is actually amazing that you can go into the material and look, because this is an X-ray microscope. So you X-ray the material and then you have an optical data collection. So this is something which is very useful in the battery industry for taking a deep dive into the metals. Next, after you prepare it, then you have to slice it. You can slice it by two ways. One is a laser cutting and a die cutting. Depending upon which technique you use, you have different microscopes to look at the end processes. You can use a very high-end electron microscope if you use a laser cutting or a light microscope. We do have automatic solutions where our microscopes are put on large XY stages so that the complete layer of the electrode could be inspected for foil burn. So this was about cell. This was about the cell manufacturing process. Now you've assembled a cell, as was explained by Mr. Chandrasekhar. So in the past, we were looking at more of an external measurement, the electrolysis and the voltages and current ratings and so on and so forth. Today, you would like to have a deep dive understanding of why the performance is good or why the performance is bad, and the safety and the recharge issues and so on. So for which, once you make a cell, we have a beautiful novel technology called computed tomography. This is very similar to what is available in the medical hospitals, where there is a CT scan. So this is a CT scan for industry, a 3D CT scan. So you have a source and you have a detector. So you can put your battery, 18650 battery could be placed over here. Then after about 30-40 minutes, depending on what you want, you would get a complete view of the battery material. So here I would like to show you a small video. Is the video working? Yeah, small video. In this video, yes, we cannot show you a battery because of NDA and other regulations. So we are showing you a plastic component, but imagine this could be a battery in a serial production, and the same methodology is applicable. So in a serial production of batteries, if you would like to inspect a batch of batteries, you could inspect it from the outside. That's easily possible, but there are a lot of defects inside the battery. As explained in the previous process, there is a lot of things which happen inside the can. Welding, you do a lot of welding and then tab welding and so on. So there are a lot of internal defects which will remain hidden unless you inspect it and understand your process. So X-raying your part is the only way to get the full picture. And it is now easier. It's available in Bangalore. It's available in Pune. It's going to be available in Chennai. So please come to us if you want to inspect your batteries. We will put it inside a machine, a small machine which is available with us, an X-ray machine, which will go into the battery and detect, is called metrotomes. It's a simplicity in CT. CT is computer tomography technology. So this would go deep inside your part. We will see in upcoming slides. You can measure outside the part. You can measure your cell structure. You can measure your wall thickness of the electrodes. You can measure your used parts without dismantling it. It's a non-destructive test. Very interesting test, and many battery companies are using this technology. It is available. Please come to us, talk to us, and we could give you, you can use this technology on a pay-per-use basis. This CT is going to be one of the important value additions in your manufacturing process, right from outline, QA, failure, or R&D. I don't want to go in detail. For those who are interested in any of the topics which are coming up, my name number is available in the chat. Please look at it. You want a separate session for your company, we are more than willing to do it for you, because we are trying to compress everything in 20 minutes. So I'll be rushing through. So this is an X-ray image of a battery where you can see the defects, what we can look at: overhang measurement, electrode defects, optimizing of space. You don't want more space because space is a big constraint, housing defects, and welding quality. Pouch cells, you can look at, this is an example of an X-ray image of a pouch cell. There is an overhang of the anode and cathode electrodes. You could look at that. You can look at them. You can look at inside and look at, there is a metal particle which is lodged inside, which is not going to be conducive for the performance of the battery. It can result in a major damage. So you can look at that and see and correct your process. Aluminum housing, if it is impinging on your electrodes, you could look at that. Tab and welding defects and glue inspection could be seen. In detail, it's mentioned here. You can measure the electrode to electrode heights. You can measure the maximum to minimum heights. So you understand what's going on inside. Pouch cells, again, there are a lot of tabs which come out and they are very fragile. And the thickness of the tabs keep getting, the foil collectors keep getting reduced. And hence the welding is very important. And the welding could go for, could be bad if the heat is more or less. So you must inspect the welding as a process, which you can do with our CT machine. Electrode defects. You have a canister, you have a battery, and you do not know why it is bad. So you want to put it in our machine, put it, and you could find out that there is a crack in your jelly layer. This can be made out, and our engineers in Bangalore have done a lot of work for the battery companies. Please come talk to us and we could give you solutions. Metal contamination, we discussed this. That's one of the major area. In pouch cell stack alignments, the X, Y differences between the stack layers are important, which can be taken care of. Cylindrical cells, again, you can understand a lot by X-raying it and looking at it inside. I'm repeating, it's not an outside measurement. You're measuring it inside. You can measure inside the battery what's going on. You can look at it visually and also measure it. Going to the modules, anyway, modules is a combination of cells. Again, similar topics, but in addition to it, there are some electronic components, metal contamination of the outside casing, and welding and large, higher capacity weldings and busbar defects can be looked at. Overhang and tab, welding defects, electronic components. This is the machine which will do the job for you. As I repeat, it's available in India at Bangalore, available on a pay-per-use basis. So please, please talk to us. We can help you out. So this is a slide summary. Now I'll go back. Now after finishing the electrode production, the quality topics around that, cell assembly and the topics around that, module assembly, I go back to battery material development. This is one of the major areas where we need to improve as a country. So what we say, see, our experience of Zeiss is about, we are in this field for a lot of years, and in the lithium battery area for about maybe 10 years or so. So our experience, this whole presentation is a college of our researchers who are sitting in China, Japan, Europe, Germany, and USA. So we have a lot of know-how. We can help you with understanding the characterizing your material content, which will result in looking at your material structure, how the properties, how does the material behave, and finally, what is your performance and how does your process work? So everything has to do in a battery is with the microstructure. So what we will do is, now we have an extensive microscopy portfolio, starting from few microns of measurement to few nanometers. I repeat, it's a few nanometers. So with this complete portfolio, we can understand the packaging, which we already saw, the assembly defects. We can look at the layer defects, porosity of the separator, go back to the particles. We can look at the individual graphite particle. We could look at the SEA formation and see what is the thickness, and so on and so forth. We have a lot of tools to do it. All these tools, most of the tools what you see here are available with us in India. That is the biggest part. That's the best part, that we want to support you. And our headquarters has invested a lot of money here, and we would like to see how we can support you. So I will now explain a little more on the battery materials, how to develop a recipe. So as you saw in the previous slides, cathode, anode, SEI, separator, binder, electrolyte. What are the topics to be measured here? Microstructure, microstructure, microstructure. That's the most important thing. Then the topography, that is the layer of a microstructure, how it is organized. Material contrast, then chemical analysis, and so on. what are the technologies? There are a lot of technologies used. We can explain all these things to you in the when we have our engineers together with us. Many technologies and many machines are available. We also provide you, as we discussed, a complete solution how to handle the lithium batteries. Now we will talk about three topics. One is what to do in a simple microscope, what you can do in an electron microscope, and what you can do in an X-ray microscopy. So in a simple microscope, you can cut open a battery, look at the layers. You will have to do a lot of polishing, processing work to see that it is ready to be viewed by a microscope. And then you can look at the individual layers, anode, cathode separator, the collectors, the copper and the aluminum collectors, and the distances, and so on and so forth. You can figure out part by part, area by area. So this is another view of it, how you can look at the layers. Now, what is that you can find out? You can find out physically, you can find out some deformation, stress. Looks like a pouch battery, so you can find out the deformation and the stress. You can find out if the particle size is not homogeneous, cracks, layer thickness, short circuits. This is the topic you can find out. So you can measure from a few microns and above. Now going forward, if we use an electron microscope, what can you do? Electron microscope is you take the part, you take a small sample of the part, you put it inside, and then there is a stream of electrons which impinge on the material. Then you get to know a microstructure of the material at a different scale altogether. We are talking about a few nanometers or tens of nanometers in which you can look at the material. Now here, this is an example of silica, which is used in the graphite to improve the performance of the battery. So, yes, you can look at the silica, and you can also look at how it swells after a few uses. So you can look at the aging condition of the microstructure. After 100 or 200 recycles, what is the change which happens? So which material changes? Which material pushes what out? And you could do all this in our electron microscope. You can section it layer by layer and go deep inside. So this is very important. And if India develops these kind of R&D, then it would be useful that we could do a lot of things. Otherwise, we are dependent on other countries for these developments. Another important thing is, again, there's a new 1865 battery and the old 1865 battery. You could see that there is 8 micron swelling which has occurred, or you can see there's 36 microns in a new battery, and it is 44 microns in a used battery. So this is, again, you understand what goes on, and you could also see that the material has undergone a lot of changes. Over here, the separator layer has undergone a lot of changes. So which will be useful for your engineers to redesign. Aging of the separator, you can understand it separate. You can understand it as the topic separator. Again, the same topic of the particle of NCM 111 or 811. You can find the 811 has very, very fine particles, and also I think using more nickel, it makes it more cheaper, and cobalt seems to be there is a supply side issue and there is an ethical issue to it. This is one particle of LCU, that is a lithium cobalt oxide, on which there is a binder material which is there. So this is the level at which our machines can view the battery, from a particle to the complete battery or pack, or the complete cell. We can also view with our technology. You can view the polymer. This polymer, when it is viewed, you need some very high-end, low-voltage technique to view it, which is available with us. These are multiple views and images of a ceramic coated separator, which you can see here. This is again an NCM 111 cathode, and this is possible in our electron microscope. Some more aging related issues, which you can study in our electron microscope after 200 cycles or after 500 cycles. One more. Now, assume that you have made a battery and you want to view it without damaging it, and you want to go into the layers of it. We do have a technology for it. This is called Zeiss Xray. This is an X-ray microscope, and the battery you can see is put over here, and there's a technology. We'll see that later. You can completely get the rendering of the battery as it is inside. So this is a physical rendering of it. So I will show you a small video. What you can do, you can inspect the specimen of the battery, and you can identify the regions which have issues, Then you can analyze those regions separately. So this is what you would see. If you can see the video on the left, that is a complete 1865 lithium-ion battery. You could go into it. You have the complete 3D structure. You can go into the battery, look at the individual anode, cathode separated layers, look for inclusions, cracks in them. So this is fabulous. And this technology is available in India, and we could make it like, as Mr. Chandrasekhar mentioned, we are related by our way of work to a lot of educational institutes who have these technology, and we can put them onto you, and we can collaborate and support you in doing these things. So I'll move forward fast. So this is again an extract from that technology. This is one more view of a pouch cell. You can view them, and this is actually 4D. You can view the changes over time, combine them together, and look at what's going on. This will be a boon for, if you have a research team, they would love this machine. This is in detail analysis of, I'll just go. This is about 500 by 500, 0.5 millimeters by 0.5 millimeter diameter. So you look at it, and then you look at a small area in an electron microscope. This is the layer. Then you keep magnifying it, and then you go to a real fundamental secondary or primary particles and see how things are working. And you can see a lot of cavities and spaces which do not which do not add value to your battery performance. Coin cells, you can go inside, look at what's going on. Another view of the same mission. This is called an Xray microscopy mission. Another view of the pouch cells, what you can do by putting it inside the XR. So you can see this is an example in a pouch cell. In the flat areas, things are fine. But when it comes to the areas where it is getting burnt, you can see the cracks. So cracks means low performance and failure of the battery. Again, another view of it. So there are more cracks, less cracks, and it goes on. So when there is a more curvature, you do have a problem. So with this input, you can control your machine and you can change your form factor accordingly. Some more aging analysis. I will go forward. This is another view of just a cathode material. When going through the cathode material, they understand this material is having a lot of small porosities and stuff inside, unwanted materials inside. Then they analyze which are the materials, which are the areas in which these materials are there. Then that is taken to a different equipment, electron microscope, and studied. And then finally, we understand what is the different material which has come in. This is called a lanthanum impurity. So this has come from a different process. So then you have to understand from your supplier from where it is coming. So finally, what could we do? So we could provide you with the manufacturing quality solutions for the manufacturing process. Then for the packaging process, different cells, we could provide you the packaging process. We saw that, and you can acquire information about your battery, segment it, analyze it in some softwares. We do have some softwares to simulate new battery designs, new combinations, and see that you get the best battery required for your customer. So this is what we started with, that we are into battery production, right from raw material to the pack assembly, and also into R&D for the recipe development. So we could give you a complete one-stop solution for all your quality solutions. Just one slide, what I have not added is if you're putting the battery onto a car for the OEMs, we do have solutions to see how how is the thermal, you have a lot of structures for the thermal cooling and so many things around it. On the BMS, we do have solutions for the measurement of the electronic parts inside. So we have a complete solution right from material to putting the whole battery pack onto a car. So this is what I had to present. My name is Manoj, sitting in Bangalore. My email IDs and phone numbers are there in the chat box. Please contact us. We have a huge team waiting to give you solutions on the battery quality issues. Thank you.